Hi everyone. Welcome to our video where we will use the definition of the derivative to find g prime of x when g of x equals 2 over x minus 2. Okay, so the definition of a derivative, just to write it out on this page, I'll abbreviate a little bit. The definition of the derivative is where f prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x over h, which is the same thing as the instantaneous rate of change. Okay, so we know that this is still instantaneous rate of change. It's just the general form for it. Okay, anyway, so with this problem, they use g though, so that's what we'll use in our scenario as well. So let's set this up as g prime of x is equal to the limit as h goes to 0 of g of x plus h minus g of x over h. So I'm just using the same equation, just changing f's into g's. Okay, and then we have our process now. Okay, so I want to find this, and I want to find this, and then we'll plug it in. All right, so let's go ahead on this one. Let's see how you feel. I'm just going to plug it straight into the equation. Let's still use our colors. Okay, so in the blue, I want to plug x plus h into the x's there. So I have 2 over, instead of x, I want x plus h, and then after that is minus 2 still. Okay, so that's what that looks like. And then I have my minus, and then let's set up in the red. Well, g of x is the 2 over x minus 2. So I just want to just plug that in exactly. And then still all over that h like that. Okay, and then so at this point, well, the blue parentheses really aren't needed anymore. I'm going to take this step. So often they're important for us. In this problem, let's go ahead and rewrite it as just x plus h minus 2 like that now. And then still minus 2 over x minus 2. And I don't really need the separate parentheses either because I have my big fraction bars which have the implied parentheses. Okay, so that's how I'm going to write it. Well, whenever you have, so this is a complex fraction. Whenever we have a complex fraction, the way that we want to simplify it is, let me write it in green. Okay, so that fraction in a fraction. So we have fractions in fractions. So that's what's called a complex fraction. To continue simplifying this, we usually multiply everything by the denominators of the small fractions. Okay, so let's multiply all terms by denominators of small fractions. Okay, and so what I mean by that, we have our big old fraction. This numerator in parentheses divided by h is this giant fraction. And then we have our, what I would say, the small fractions inside the giant fraction. Okay, so I need to multiply. Let me actually get rid of this arrow. I don't think we need the arrow there because that's going to get in the way. Okay, so what we need to do is multiply everything by these denominators. So that means the way I write it, I usually just show it in the top as x plus h minus 2 times x minus 2. Okay, let me kind of cloud that. Okay, so that's what we're going to do. And then whatever you do to the top of a fraction, do to the bottom. So x plus h minus 2 times x minus 2. Okay, so that's what needs to happen. And then this will distribute. So this whole thing distributes to this term, and it distributes to this term. So we'll simplify that. And what we get, so we write our limit as h goes to 0. And then when this in the green multiplies this first fraction, well, this x plus h minus 2 will cancel with that x plus h minus 2. So we'll be left with just the 2 times the x minus 2. And then we'll have our minus sign. And then when these distribute, let's go ahead and I'll do it in purple just to show a little bit. So when this whole thing distributes, this x minus 2 will cancel with that x minus 2, and we'll be left with that 2 up top. So minus 2 times this x plus h minus 2. So what's kind of happening is it's almost like it's cross multiplying, like this x minus 2 is multiplying that 2, this x plus h minus 2 is multiplying that 2. Keep the minus, keep the parentheses, but it's also, so it's not just cross multiplying. So again, it's kind of like it is. The bottom also needs to get multiplied by that though. So I have h times x plus h minus 2 times x minus 2 all on the bottom. On the bottom, we usually leave it as is because this h, that h that I'm now putting in parentheses, should cancel out eventually. Okay, so in one really big step, it simplifies it pretty nicely. And then now what we'll do is just distribute. So now it becomes the limit as h goes to 0 of 2x minus 4. And then minus 2x minus 2h plus 4. Okay, so I distributed the negative 2 through, and then the denominator is still the same. Usually we just leave that alone like that. Okay, and again, if we did things right, we mentioned in a previous video that we should only be left with h terms once this is fully simplified. And well, it sure looks like it. 2x minus 2x is 0, and then minus 4 plus 4 is 0. So we're left with the one h term that's the only thing in the numerator. Okay, and I didn't give myself enough room. Let's put it up here now. So we have the limit as h goes to 0 of just negative 2h over h times x plus h minus 2 times x minus 2, like that. Okay, and then, well, our pattern is continuing. The h here needs to cancel with that h. And so then we have this limit. The limit as h goes to 0. H's cancel. I have negative 2 up top. And then x plus h minus 2 times x minus 2, like that. And then now I can plug the h going into 0 to the one left over h. And if we do, we get that this is negative 2 up top over x minus 2 times x minus 2. Okay, because that h is 0, so I don't need to show it. So it's just x minus 2 is left over, and then x minus 2 in the second one. Well, x minus 2 down below is times itself, so often we'll simplify that to be negative 2 over x minus 2 getting squared, like that. Okay, so there it is. So that is our answer. And I'm just going to kind of crowd that one out. So again, this was our g prime of x that all of this work led to this answer. So g prime of x is negative 2 over x minus 2 getting squared. Okay, and again, this just represents the general rate of change for this function, which might mean we could plug different x values in to see different slopes, but for now, that's it. Okay, so that's all I'm going to do on this video. Let's save this for a separate one. In case you feel good about these square root ones, you can maybe move on, or at least maybe click on it to fast forward and see if you got the right answer, if you wanted to try it by yourself. But let's save that for another one. Okay, so anyway, so thanks for watching. If you have any questions, let me know, and I'll see you next time.